USGS as a research geographer. And I would like to introduce Sophia Liu, PhD, who is what they call a Mendenhall scholar, which is a competitive fellowship program here at the USGS. And she is investigating how you can integrate official and crowdsourced geographic data. She received her PhD in 2011 from the University of Colorado Boulder in the Technology, Media, and Society Interdisciplinary Program. And in 2006, she was awarded a National Science Foundation Graduate Research Fellowship. Her dissertation research focused on the use of social media in historically significant crises and the emergence of socially distributed curatorial practices to manage crisis information. So I just wanted to say that if we have people who want to convene afterwards at the tavern, we're inviting you. We cannot pay for your drinks, but if you order nachos, we can pay for those. Without further ado, here's Sophia.
Thank you. Thanks so much, and I'm sorry if many of you here were just waiting and drinking beer, so sorry for the time change, but thanks so much for this opportunity to talk with you. I had just transferred to St. Petersburg, Florida on January 13th, so fairly new to here. I came from Golden, Colorado, working with a person named Paul Earle. He directs the operations at the National Earthquake Information Center at USGS. So I've had the opportunity to work there since November 2011, and I'm here for the rest of the year. So I'm excited to work with Barbara Poor, who's my other mentor on this Mendenhall. So this is where I came from. And this was just right outside my office window, but I'm very excited to be here. You know, I just actually took that this morning from outside my window, or outside my house. So I'm really excited to be here, and also really excited to learn more about marine science. This is not a field I'm very familiar with, so this is a little bit of a different audience for me, but hopefully I'll give you a new look into thinking about social media. And just want to give you an outline of my talk as well. I want to give you an idea of my research background since I come from a different place. Also give you some details of the Mendenhall research that I had proposed to work at USGS. And then I'll discuss some of the high-level concepts of crowdsourcing and give examples of crowdsourcing workflows in particular. Then I'll offer a framework for basically understanding how do you deal with the interface challenges with integrating official information with crowdsourced information from social media. So after that, I'll then discuss what's called the Tweet Earthquake Dispatch project, or TED. It's a project I worked at the National Earthquake Information Center with Paul Earle. And then lastly, I'll share some of my research plans for my postdoc here in St. Pete. So unlike many of you oceanographers and marine scientists here, I imagine, I come from a different background. In 2005, I began my PhD. I think Barbara gave a lovely introduction to the interdisciplinary work I did. I worked at the Natural Hazards Center as well to really understand disaster research and the domain expertise needed to understand how to develop and design technology for the crisis domain. So I was a part of a lab in working with Professor Leisha Palin, who's in computer science at University of Colorado. And basically, we developed the foundational research for what's called crisis informatics. That is really a field that integrates domain expertise from disaster research and integrates it with human-computer interaction techniques of technology design. So crisis informatics really considers itself as looking at the entire socio-technical arena of disasters to really account for the information, space, and flows. How are people sharing and moving information around during all phases of a disaster? It's also about applying HCI kinds of techniques to really understand what are users' behaviors, what are their needs when they look at this information, and how do you make it helpful for operational purposes during crises. So traditionally in emergency management, you have information coming from the official side through public information officers, as they call it, PIOs, and pushing it out to the informal public side. But what's actually always happened in practice is members of the public and all sorts of people, you ask your neighbors, you ask people you know, information about a disaster. So information sharing always is occurring. It's just happening at a much faster and in multiple ways now through technology like laptops, being connected online, using social media. People are sharing more quickly and more information. But what is new actually is how this information is being pushed to the public side and what is the official side doing with that information. So the challenge is partly what do we do with this information, and then how do we maybe use that information and push it back to the public for operational purposes. Now, during my dissertation, I had focused a lot on how is information being shared on the public side and what information is interesting for people to share. But for my Mendenhall research, I'm looking at the interface of how do you integrate and look at the challenges of sharing information between the sort of official side and then this more informal public side. As people increasingly, generate eyewitness reports using information and communication technologies like mobile phones and camera phones, taking photos, we have all this information now, but we don't have enough processing capacity to turn this actionable or this wasted crisis data into actionable information. So that's the real challenge right now. And although this is what most people think of with social media in terms of how people are sharing, photos of what they see during a disaster on Facebook, it's not just really Facebook that's interesting. It's what they're doing with these different social media services. It's the different networking technologies to collaborate together that's fascinating, because what people are really doing is using these social media services to curate this data, this content online in real time, and often in a way that can actually help save lives. So you might be wondering, what do I mean by this word curation or curating content? So just think of curation as a form of information management. And in the tech world, curation has really become this buzzword of trying to figure out how do we survive this data deluge, and how do we find the signal within the noise of content that's online right now. So more specifically, some people have been using the phrase social beats search, or I'm sorry, I think I just closed it. Or Google versus Facebook. So what this means is people are increasingly relying on their friends or their social networks to find relevant, interesting, and reliable information. Meaning our trusted network, our friends, are becoming our filters for content online. But it is also worth pointing out that, that there's sort of an exhibition or editorial aspect to curation, where you're arranging and juxtaposing different kinds of artifacts together to tell a story or to create some kind of an experience for the viewer or user. So to some degree, these crisis map mashups that began to emerge, particularly after the 2007 California wildfires, people were using Google My Maps and just creating their own maps, annotating it. And this really helped to, these maps are basically similar to a curator's exhibition space, like at a museum, where they're really integrating multiple sources of data together and then telling a story in a geographic way about what's happening, and sometimes in real time. So the crowdsourcing efforts that occurred after the 2010 Haiti earthquake largely involved curating content using these social media services. So there are some really interesting improvised ways and innovative ways of using Google Docs and Google Groups, but also Skype to really make it easy to collaborate with different people around the world on how to respond and help in response to the Haiti earthquake. So a lot of what I just discussed is the foundation of my Mendenhall research. It really is to investigate the integration of official information with crowdsourced information following disasters, and specifically with a more geographic or mapping aspect to it, looking at how are people mapping this information, or how can it be mapped. So there are 4 research questions that guide my project. The first one is, what kind of crowdsourcing activities have occurred in the crisis domain? The second is, how has crowdsourcing in the crisis domain evolved since the 2010 Haiti earthquake? The third is, what interface challenges exist when integrating official information crisis data with crowdsourced crisis data? And then lastly, how can crowdsourcing be integrated into USGS products and services for operational purposes in the emergency management domain? So to answer these questions, I considered these different types of stakeholders, and these could be potential research participants. So I didn't talk to all these types of folks, but many of them that had this kind of background. But also consider each of these stakeholders as different types of crowds. As later on in my talk, I'll define crowdsourcing. So think of these as different kinds of crowds. So that could be the emergency practitioners, what people are calling volunteer technical communities, which are the volunteer communities that are emerging in response to disasters that want to help, particularly using online technologies. You have tech companies like Google, crisis response team. They have their own team now focusing on this. Satellite imaging companies like Digital Globe and GOI. So these are just different types of people that I think are important to consider. But in terms of some of the research methods that I've been using to conduct this research, I've done a literature review of what has been discussed in response to the Haiti earthquake. There was a proliferation of publications just understanding what happened after Haiti, both on the official side, but also this new public participation side using technology. I've also conducted some informal interviews and developed some focus groups where I talked with these different stakeholders just to get an idea of what are some of the challenges that they've been facing and how do they understand and apply this idea of crowdsourcing in their work. I've also participated in multi-stakeholder meetings in person. There's been specific meetings developed on crowdsourcing and crisis mapping, so I've been participating in those and getting involved. But I've also done virtual observations and participated online in crowdsourcing efforts that have occurred. And this is really what some might call virtual ethnography, but really just doing observations online, not in person. And lastly, I've been using some geospatial visualization tools just to analyze this different crowdsourced data. Now, just to give you a sense of some of the findings from the literature review, basically data from the crowd is leading to information overload. How do we look at all this information is a real challenge. There's also inconsistency of this crowdsourced data because there's really no data standards. There are now data standards that are starting to be developed, but really there's a variety of different kinds of data that exist out there that's not easy to integrate. There's also no direct interface between the informal and formal efforts. So there's real challenges, particularly with the policy and organizational side of integrating the efforts together. So there's really now an urge to formalize crowdsourcing efforts in the crisis domain, whether it be through education or through actually changing policies to make it easier to facilitate, or making social media even accessible in federal agencies has already, has been a challenge initially, but now they're more accessible. And then lastly, there's some verification issues and assumptions with crowdsourced data. Verification is often brought up as an issue, but I think there's a lot of assumptions associated with people thinking crowdsourced data is by non-experts. And I think there's a more complex reality that occurs. So just to kind of discuss, there are trade-offs to using crowdsourcing, but I wanted to go through some of them to give you an idea of what assumptions people sometimes make, but what happens in reality. So people often emphasize that there's verification and authenticity issues, but what tends to happen in practice in social media is a lot of self-policing. People want to be the one to say, hey, this person is actually sending out bogus information, and that actually ups their reputation. It really gives them more social capital. There's also too much data with varying quality, but with that, there's the speed of that information can be sometimes more important, or in this case, currency can sometimes trump the accuracy of that information. There's also, an aspect of crowdsourcing as a form of bias sampling. You're just kind of choosing the crowd or some kind of crowd to give you information. But sometimes that's what you want. You really maybe want to specify a specific crowd, and sometimes the crowdsourcing that occurs might provide on-the-ground real-time reports. That is what you need. And then lastly, crowdsourcing is often seen as really unfiltered and irrelevant content. You might sometimes have spam bots pushing out information. But the value is that this information can circumvent traditional censorship that occurs with mainstream media in pushing out information. So this information, like from Twitter, for example, or Facebook, is much more publicly available to people than what you find in other kinds of media, like mainstream media. So after exploring these different issues of crowdsourcing and what's emerged around the use of this data, it seemed valuable to try to unpack this concept and to really understand what does it mean for emergency situations. So this is one way of answering one of my questions, which is what kind of crowdsourcing activities have occurred in the crisis domain? And most people started to hear this word crowdsourcing in 2006 when Howe coined the term in his Wired magazine article. And it basically means it's an open call to an undefined and generally large group of people. So that's the basic concept. But I think it's important to realize that it's a little bit more, there's more granularity to what actually happens in practice. So I've developed a typology of crowdsourcing for the emergency management domain. It's to really think of and specify what are the different types of crowds and sourcing activities people actually have been engaging in. So in terms of these, I'm going to give you some examples from the Haiti earthquake just to describe some of these terms. I won't go through all of it, but for survivor sourcing, there was a short code that was developed after the Haiti earthquake where it asked people, and particularly survivors, the affected population, to text message their needs. If they were trapped or if they needed food, whatever it might have been, they asked them to text message using this short code. So in this case, they were asking the survivors for information about their needs. And so that's just an example of survivor sourcing. Now, diaspora sourcing is really trying to tap into the diaspora, and this tends to be people who have sociocultural expertise. Now, in the case of Haiti, the Haitian diaspora had the expertise of being able to translate these text messages that they were asking people to send out from Haitian Creole into English, but particularly English, because there were a lot of international responders. Most of them knew English or some extent of that. So that's an example of diaspora sourcing, where you're asking the diaspora who has expertise not only in the language, but also in the location of where some of the things that people are referencing in their text message, where they are, because they've been to Haiti, they know the location in that area, the cultural area. I won't go into the other social network sourcing, but in terms of expert sourcing, this is just to really point out that there aren't just non-experts that are doing crowdsourcing. For example, there's a group called, or a community called GIS Core, and they are basically a group of GIS experts that decide to volunteer their time to respond to humanitarian crises that need some kind of GIS expertise. And that does happen quite a bit. You have a lot of imagery data coming in, satellite imagery, expensive satellite imagery data, and it needs to be processed by humans. So that's what they provide. And so there are experts that are doing these kinds of crowdsourcing activities. Now, in terms of types of sourcing, there's a phrase that's being put out that's been around for quite some time called crowdfunding. Now, an example of that with the Haiti earthquake was the American Red Cross pushed out a text messaging campaign where they asked people to text message to a short code, and that would then allow you to donate $10 or $20 just from your credit card statement and your cell phone bill. So that was a really good example of a very successful effort of doing crowdfunding. I mean, they received quite a high amount of donations just by doing it through text messaging. Now, crowd tagging is something else that's occurring more. You have volunteers or a crowd look at a map and tag it for noting areas where there's damaged buildings or damaged road, whatever it might be. That happened quite a bit also after Haiti. Now, crowd curating is just thinking about, I skipped the crowd mapping. That's an example of that that occurred after Haiti was how the OpenStreetMap team, which is a group of volunteers that map OpenStreetMap, which is just like a wiki version of Google Maps where anyone can annotate this map. And they decided to do that for Haiti because there's really no up-to-date map of Haiti. And this was really important for emergency responders to understand where they should go to then help find some trapped people, to help provide some shelter or food. So developing that map was really key, and they were able to develop it very soon after the Haiti earthquake through crowd mapping. And then crowd curating is just thinking about a set of activities, tagging, mapping, but basically a set of activities that a crowd is doing together in a distributed way to help make this content more easily available. And then the other aspect of this typology is really thinking of how are people moving beyond sourcing or beyond that crowdsourcing aspect. So there's a concept called crowd feeding that's been offered, where it's really thinking about how we take information from the crowd, but really how do we also feed it back to the crowd? What can we offer them back to the crowd to make it easy and also beneficial for them? Another concept is crowd seeding that's been offered. So crowd seeding is really thinking of a more strategic form of crowdsourcing, where you're pre-identifying certain people that you want to help facilitate the crowdsourcing effort. So there might just be certain people that you know will help engage the people in the community to help with the effort. And so there's some really interesting examples of that. But what occurs more in practice is people doing more crowd harvesting, taking existing data from online, so Twitter, for example, where it's publicly available, and just harvesting this data from the crowd. So the crowd is not really doing anything specifically. They're just tweeting, they're just Facebooking, but we're mining that data to see if we can get information from it for science purposes, for emergency response purposes. So to give you a more concrete example of how to apply these concepts, there's this concept of did you feel it? I don't know if any of you are familiar with did you feel it. It's basically what I call a form of survivor sourcing, where it's an internet questionnaire that's asking the affected population who's felt an earthquake to basically answer a set of multiple choice questions of what type of shaking they felt. So basically this did you feel it internet questionnaire then turns these qualitative observations into and quantifies them so that they can be fed into a series of other earthquake products at the National Earthquake Information Center. So one product would be, for example, the shake maps. So a lot of the data that people provide and just filling this questionnaire out actually gets fed into a lot of other official products at the USGS. Now the other project, the Tweet Earthquake Dispatch project, which I'll explain later in my talk, is an example of what I would call survivor harvesting. We are trying to detect earthquakes just based on harvesting Twitter data. And I'll explain a little bit more, but that's just, people are tweeting out that they felt an earthquake and we're just pulling that information from Twitter. So what is beginning to emerge with the development of this concept of crowdsourcing is these workflows. And this is a way to really formalize crowdsourcing in the emergency management domain. So I'm going to go through and describe some of the workflows, but this is a way to answer the research question, how has crowdsourcing in the crisis domain evolved since the 2010 Haiti earthquake? I'll specifically explain this, what's called the Standby Task Force workflow, and then another one called the Civil Air Patrol imagery workflow. So the Standby Task Force volunteers call themselves digital humanitarians. They basically emerged after the Haiti earthquake. It was in response to people doing a lot of improvised efforts after the Haiti earthquake, and this was a way to formalize their efforts with volunteers. So a lot of people call them volunteer technical communities or VTCs, but they basically have organized themselves into these different teams. So a media monitoring team, a geolocation team, a team that develops the report, a team that analyzes the data, a team that verifies data, a team that focuses more on just getting text message or SMS messages, and so on. So what's interesting here is that they're often activated by official agencies. So the UN OCHA, or the Office of Coordination for Humanitarian Affairs from the United Nations, they've asked them to help them with monitoring data online for certain disasters. Also, the U.S. Agency for International Development, or USAID, has also worked with them as well. Now, the main thing is that they want these agencies, or those who are asking them to the activating agencies are being asked to identify what type of crowdsourced data they need to make decisions. So that's really what their responsibility is, to focus on explaining what kinds of crowdsourced data do they think they need. But it's now the SBTF teams and their volunteers, it's up to them to decide how can they use a variety of social media and networking tools to curate this content. So just as an example for the geolocation team, they are using Skype. They have their own dedicated chat channel or conversation. They have a series of Google documents to collaborate and share this information so that multiple volunteers can look at multiple kinds of information. They're using Google Earth, OpenStreetMap, and Mapbox. So there's a variety, a whole ecosystem of social media tools that are being used. So the live mapping activities are really done through different teams and in a distributed way. They are using some official reports, but they are also primarily focusing on social media data, because that is really the kind of data that a lot of federal and official agencies are not able to understand how to process well. But this standby task force has been able to do that. And lastly, the Civil Air Patrol is the... Hi. The Civil Air Patrol is an official civilian auxiliary for the United States Air Force. And they are tasked to collect aerial imagery sometimes as early as 6 hours after a disaster. So they can provide some really helpful imagery for folks like FEMA. Now, people from different organizations, so the Civil Air Patrol, FEMA, the National Geospatial Intelligence Agency, GIS Corps, the Humanitarian OpenStreetMap team, Esri, and even folks from Lockheed Martin, they all came together at an exercise at what's called Camp Roberts, and it's called Relief. And it was an exercise that occurred in August 2012. And they developed this disaster imagery workflow really to just make it so that this imagery could be categorized by the crowd more easily. Because what basically happens is the Civil Air Patrol takes a bunch of photos, and then gets put on a CD and given to the incident commander. But then it just kind of does not get looked at. There's so much data, that is given to him or the commander in general that they are not able to process it. It has been put into the HGDS, or the USGS's hazards. I'm forgetting the whole name of it. The hazards data distribution layer. It basically is sitting there, but it's not being looked at very easily. So the question is how can we make this data mined more quickly in real time so that it can actually inform the response efforts by federal agencies like FEMA? So after Hurricane Sandy, they decided to implement this disaster imagery workflow that they developed in August by developing this website. So this allows the crowd to basically classify this image as showing either light, moderate, or heavy damage. They also developed the tool and adapted it over time so that you can move. This is where the cursor is, and you can move it over so it will actually zoom into certain areas, since it's kind of hard to see some of the images here when it's a faraway photo. So basically, they just developed this website. Anyone could go to it, and anyone can help basically classify this photo. But there are also experts that looked at this. So the GIS Corps also participated in classifying these images. And basically, they tried to get about 29 reviewers on each photo to make sure that they had a variety of folks looking at it and providing a common decision on if it was light, moderate, or heavy damage in the photo. So the goal was to see if this kind of processing of this imagery could help FEMA in particular with their post-disaster recovery and response, as well as planning operations. Now, one of the biggest hurdles in these crowdsourcing workflows is the interface between crowdsourced information and its use by official agencies for operational purposes during disasters. So I developed this Stop Interfaces framework to understand the opportunities and challenges with formalizing crowdsourcing and how to integrate the information together. So this is a way of answering my third question: what interface challenges exist when integrating these different types of data together? Now, like many of the folks that are in this field, I created my own acronym. So STOP being, my version. S just being sociocultural, T being technological, O being organizational, and P being political or policy oriented. So sociocultural, what I mean by that is The real need to understand what kinds of trusted relationships are we developing with our stakeholders and how important that is over time. This is also just important in understanding when we engage with people on social media, how we're developing trust and how that affects how we view people's data in terms of its verification aspects. Now, we also need to understand the differences in data sharing values and practices between different stakeholders. So at the USGS, most of our data is in the public domain. So anyone can just take our maps and just, not even include our logo, but just use it, share it, annotate it, do something with it. But that's not always the case when you're working with, say, satellite imagery companies where they've spent a lot of money just taking this imagery and they don't want to just freely share that imagery. But during disasters, sometimes people feel more philanthropic, so that changes. But that's, I think, also something to consider, that not everyone wants to share the data. It's also important to understand how reputation can influence authenticity and verification of crowdsourced data. So if I know Barbara, who is my mentor, is tweeting out information, I'll probably trust her information more so than someone that I just kind of came across on Twitter because I might not know their background. So sometimes understanding, what people's reputations are online and offline can be really key. And lastly, there's really a push to professionalizing crowdsourcing through training courses. So there's been a lot of the development of online courses to understand what crowdsourcing is in emergencies and help provide people with the resources to do these kinds of crowdsourcing activities in their own agencies. Now, in terms of the technological interface, which is maybe what most people think of in terms of interfaces, is really trying to develop some agile, field-tested technology using both low-tech and high-tech kinds of solutions. Really the key is how do we design user-friendly interfaces? There's a lot of data out there. How do you get people to understand this data easily, especially for emergency response purposes? There's also an urge to develop application programming interfaces, or APIs, and this is a way to make data much more easily accessible, but also to allow people to use that data for their own purposes. There's also a push to offer open source platforms and use more open data standards, so that way there can be more interoperability between people sharing data across different agencies and stakeholders. And lastly, there's a real need, not really lastly, but the important aspect of the technological interface is how do we start to use machine learning, and specifically what's called natural language processing, to address some of the big data issues with mining text data. So you've got all this social media data, you got a bunch of text messages like from Twitter, you have Facebook, you have all those photos. How do you mine all that data? And there's a real need to use these kinds of techniques to understand it using machines, not just manual human processing. Now, some of the more important challenges are the organizational interface. And this is really understanding, one example is just coordination and collaboration when you have vertical and horizontal organizational structures working together. It can be a real challenge, but sometimes it's recognizing how crowdsourcing can strengthen or what some people might feel as threaten the organizational culture and preserve institutional knowledge. So, crowdsourcing has been of interest but also concern, because what happens is you have the crowd suddenly analyzing data that scientists typically do, or professional analysts. So this feels more threatening for the typical organizations. But I think that the real benefit is to think of how can this data augment existing information, and how we need really different kinds of sources of data to respond to a disaster in this case, in this domain. There's also a need for allocating sustainable resources and investments. This is really a challenge when a lot of these people that are volunteering and working on these crowdsourcing efforts in their agencies tend to be doing this in their volunteer time. They're not being paid, or there's not been a full investment to look at this specifically. So this is really, I think, an important challenge as well. And then there's also conflicts in business models with data sharing licensing restrictions. So we're dealing with Facebook data, Twitter data, satellite imagery data, they all have very different licensing agreements and very conflicting ones. So I think that's an important issue to look at. It also leads to basically the political and policy interface challenges. So a lot of governmental policy and laws really need to be adapted in terms of the networking world we're living in and social media data that we have access to now. But the real challenge that federal agencies face is having to deal with the restrictions and protections around sensitive and personally identifiable information. So as a federal agency, we are not allowed to look at citizen data. We're not trying to monitor, citizen behavior, but how can we look at some of this data, legally to be able to inform response efforts, I think is the key. But there are a lot of binding legal obligations around sharing large and expensive data like satellite imagery, and there's a need for creating more agile data sharing policies pre and post disaster. There tends to be a lot of, or sometimes what happens in practice is the sharing of baseline data during a disaster, when a lot of this data could be shared beforehand and processed beforehand, because there's a lot of data coming in during a disaster. So I think there's a need to recognize how to adapt these policies and address sort of the issues of different business plans and backgrounds of how do we preserve this data and share it widely. So these interface challenges have come up with the project that I'd worked on called the Tweet Earthquake Dispatch Project at the Earthquake Center. So in working on this, I began looking at my fourth research question, which is how can crowdsourcing be integrated into USGS products and services for operational purposes and emergency management. This is a small project that happened, that started in 2009 with Paul Earle, a mentor in Golden, Colorado, but it's evolved since then, and these are just some of the contributors to this project. Now, there are three ways in which we are approaching the use of Twitter during the initial earthquake response period. So one is to broadcast alerts of strong earthquakes. Then it's to do event detection as well as event characterization of earthquakes. So we have a Twitter account specifically for this to just push out information of strong earthquakes that we have officially recorded seismically. So this is sent out at the exact same time when our earthquake notification system, or ENS alerts, get sent out, whether it be through text messages or email alerts. We have about 34,000 followers at the moment. But the other aspect of this TED project is really more the TED system. We've developed a real-time earthquake detection system. Now, I won't go into all the details here, but I'd be happy to discuss them in the Q&A if you'd like to learn more about it. But the real core of this system is based on this simple algorithm. Once we have filtered the stream of Twitter data for earthquake-related tweets and people who actually felt the earthquake for those tweets, we then generate a tweets per minute time series by calculating the tweets by every 5 seconds intervals. And then we generate the detections using a short-term average and long-term average algorithm, which is a very similar algorithm used in seismology to detect and time seismic phases. So it's just the same idea of if there's suddenly high seismic activity, we think it's an earthquake. So if there's a high number of tweets, then we think it's an earthquake. Now, when our detection algorithm gets triggered, then it generates 4 TED products. I have some screenshots of each of these that I can go into detail, but I won't explain too much of them here at the moment. Instead, I'll just give you an example of one of our TED detections. So this was the 4.0 magnitude earthquake that happened in May, just this past October. Now, 39 seconds after the origin time of this earthquake that happened in Hollis Center, Maine, we received our TED alert. I was actually in DC at the time, but I received this on my cell phone, and this alert occurred about 32 kilometers from the epicenter. Or our location estimate was Portland, Maine, which is sort of around here. And that is about 32 kilometers from the epicenter, which is the Hollis Center. Now, this event had about 2,754 tweets per minute, which is fairly high, so there's a lot of activity, a lot of discussion. And what's interesting about this example is that there are not a lot of earthquakes that happen in Maine. So there's probably more Twitter activity of people talking about it, trying to figure out what that was that they felt. There was also, you'll see if you create a sort of a time lapse of the tweets that we received over time during this event, the initial tweets concentrated near the epicenter, so closer to Portland, Oregon. But then you see the later tweets concentrating in Boston, which is right here. This is 254 is the cluster of tweets there. And that's partly because you'll see a higher Twitter population in Boston than, say, in Portland. But really, to show you how fast this algorithm works, this slide shows, how fast these alerts came out. And the red circle shows the location of the P wave of when our TED alert was sent out. So if you compare the location of the P wave, which is the red circle, to the felt area of the earthquake, which is these did you feel it observations that we collect, which is crowdsourced, you can see that I received this alert actually before tens of thousands of people actually felt the earthquake. So all these other people had not felt the earthquake just yet, and so we had already got our alert 39 seconds after the earthquake. Now this slide also shows some of the seismograms in the area. So this is a nearby seismogram, the closest one, and this was the origin time of the earthquake, and we sent out our alert at this time, and this is what the seismic station was reading. So we actually sent out the alert before the S wave arrived that station. This is another seismic station, and their seismogram, it's kind of over around here. That's in Pennsylvania. And our TED alert also, since it was so much further away from the epicenter, our alert was obviously sent much earlier than it receiving the seismic information for that station. So just to kind of give you an idea of the performance of our system, our real-time detector, during an 8-month period from February to October, we had about 729 detections, which is on average about 3 per day. And our tweets per minute ranged from 29 tweets per minute to about the 2,754 tweets per minute from our example, the main one. And then just for testing purposes, we selected a random month to test the performance. So we focused on July of 2012. There are about 87 detections, which is again 3 detections per day. And so 82 of those detections, or rather 94% of these alerts, correlated to true seismic activity. So we found 69 of them in a seismic catalog, so it was officially recorded. But we also found 13 of these detections could be verified looking at seismograms, but that were not recorded officially in the catalogs. And then 5 of the detections, or 6% of these detections, or the alerts, were actually false detections. So these tended to be like earthquake songs that had the word earthquake in it. There's also a baseball player that I think has a earthquake kind of a connotation to it as well. So those pop up as detections. But essentially, we have a fairly low false detection rate. And then the shortest alert time was 24 seconds after the origin time of an earthquake, which is fairly quick. It's much quicker than some of the other, from our seismic stations. They tend to take a little bit longer, 5-10 minutes. And usually our USGS earthquake information gets sent out 15 to 20 minutes after the origin time of an earthquake. And that's usually when most people know about it. But in terms of those in the affected area, they'll obviously know right away. But the average tends to be a little over a minute, and then the longest alert time is about 3 minutes and 10 seconds in this July period. And then lastly, in terms of the earthquakes that we detected, the lowest magnitude was 2.5, the average magnitude was 4.6, and then the highest magnitude was 6.4. Now, there are trade-offs to these TED detections. In terms of the advantages, the TED detections can be a lot faster than our seismological detections. And they detect small but widely felt earthquakes. So people tend to tweet about more smaller earthquakes because there's not a lot of large ones all the time. And a lot of the large ones that occur sometimes are in areas where there is no human population and no Twitter population for that matter. But we are detecting small earthquakes that sometimes get missed in sparsely instrumented regions. So then the tweet text can provide also qualitative information on the shaking level. And it's really a relatively low-cost way to detect earthquakes just using Twitter data. In terms of the disadvantages, TED just really is meant to augment but not replace seismically derived data. So this is really a small number of detections compared to the large number of detections that we get teleseismically, officially. And then these tweets are really only a qualitative indication of shaking level, not a quantitative measure. And really, there are a lot of geocoding errors of tweet location. They all vary. They're not a lot, but there's some tweet geocoding errors, and sometimes some tweets don't have any location information. So that's something to consider. But just to kind of go back to the stop interface challenges, I really want to point out that we only have about 30 people that are looking at these detections. There are folks from FEMA, there are folks from, there are seismologists around the world that are looking at, they're receiving these detections. We don't have, it's not a public system, and it's in part because we have a false detection rate still. So we don't want to push this information out just yet publicly. We also need to use machine learning or natural language processing to understand the tweet text data in a wider scale. And then we really need it really requires more sustainable resources to support this TED system. But also, in terms of the political and policy interface challenges we face, there's personally identifiable information issues that we have to consider. So we've done a one-way encryption in terms of not collecting on users' name, but just on their tweet text and what they've sent out. So just to kind of wrap up and giving you an idea of what I plan to do with my postdoc here at USGS in St. Pete. I have some publications that I'm working on, just describing the typology I had mentioned earlier, explaining more about crowdsourcing and the evolution of these volunteer technical communities. And then lastly, looking at and describing different case studies of crowdsourcing workflows and the stop interface challenges each of them face. But what I'll be doing is developing my own crowdsourcing project here and collaborating with a USGS research oceanographer named Nathaniel Plant. He was the one that hosted last week's seminar series, and it's really thinking about how do we crowdsource coastal change. So after Hurricane Sandy, Nathaniel Plant and his team took post-disaster aerial imagery to compare these images to ones they took a few years ago as a baseline survey of the coastal changes along the East Coast shoreline. Now, they curated their collection of 10,000 photos of their pre and post Sandy photos to show these compelling juxtapositions of the coast over time, so over a period of 3 or so years, and particularly after an extreme storm. So after showing this Civil Air Patrol crowdsourcing workflow to Nathaniel Plant, we thought maybe we can do something similar. So we were thinking of crowdsourcing coastal change in terms of the analysis of the imagery that's being taken. So the question that we're going to try to explore is how well does the crowd analyze coastal change imagery compared to the gold standard of experts. So we'll get experts around here to just look at the images and tag whether the images we see here show any inundation, overwash, dune erosion, or dune collision, or just no change at all. And see if the crowd can also do a comparable kind of analysis. Now, the real purpose of this crowdsourcing project is intended to refine the predictive models of coastal change vulnerabilities. And it's really to help scientists analyze imagery more quickly or more thoroughly to improve the ground truthing of these models. I mean, there's a lot of data out there. How can we look at certain ones, or how can the crowd help with some aspect of that? But we are also considering, how can the crowd also provide images during the extreme storms to help ground truth, what actually happens in practice during a storm. So just really to find, as a conclusion, these are some of my intended research contributions, and they're threefold. One is, how to developing a crowdsourcing typology for the emergency management domain. This is a way to expand the crisis informatics theories. producing some technology design implications and proof of concepts that would offer examples of how do you, integrate different kinds of data, particularly crowdsourced data with official data. And then lastly, offering some policy implications for how do you implement a crowdsourcing workflow for operational purposes in emergency management. So with that, I just want to personally thank Barbara Poor for, her passionate interest in wanting to work with me and being my mentor during this postdoc fellowship, and also just the admin and IT folks and other folks that I've met recently at the Coastal and Marine Science Center at USGS, just down the way. And so I'm really excited to work here, and I